Single rebound questions video 2. In this case we're looking at 2017. It's an ordinary level question. Let's read through the question, and my biggest tip here is, again, break the question into sections. So a ball is fired vertically upwards in a room with a smooth horizontal floor, a smooth horizontal ceiling. The room is of height 3.15 meters. The ball strikes the ceiling with a speed of 12 meters per second, and the coefficient of restitution between the ball and the ceiling and the ball on the floor is 3/4. So the ball is just about to hit the ceiling. When it hits the ceiling and rebounds back, we need to apply the coefficient of restitution for the velocity after that collision. The ball will then fall down, hit off the floor with a particular speed, rebound off the floor, so we'll have to apply the coefficient of restitution formula there to get the speed it bounces off the floor with. And then it will rise up, and we'll see what happens then after that. What are we looking to do? Find the speed of the ball immediately after striking the ceiling. So we have an initial velocity of 12 meters per second going into that collision. If we apply the coefficient of restitution formula, which is minus E is V over U, what we get is a velocity of minus 9, which means that the speed is 9, but it's going downwards, which is what we would expect. The velocity after the collision is decreased, and it's also going in the opposite direction. Part 2. Investigate whether the ball strikes the ceiling again after rebounding from the floor. So there are 3 sections to this question. The first one, we need to find the speed it hits the ground with. So it's going to travel 3.15 meters downwards. It'll have an acceleration of 9.8 meters per second squared, and the initial velocity is 9 downwards as well. Then it will hit the ground. So if it's a rebound, we'll have to apply E is equal to V over U. So we'll have 3/4 or 3/4 is our E, and then we can work out the velocity after it rebounds off the floor. And then the final part is investigating whether the ball strikes the ceiling again. We're going to test whether the ball will have a velocity after rising through 3.15 meters. That's why I'm going to do it. Is there a velocity that the ball will have when it strikes the ceiling again? If it has, it will strike the ceiling. If the velocity is 0, it may just reach the ceiling, and if the velocity is negative, it won't reach the ceiling. So, the first part, the speed it hits the ground with, we used V squared is U squared plus 2AS. Initial velocity is 9, the height is 3.15, and the acceleration is 9.8, but they've put in a 10 there for simplicity. V then works out as 12 meters per second. Second part, what is the speed it rebounds from the ground with? So we use the coefficient of restitution formula, and we got 9 meters per second is the speed it rebounds from the floor with. And then if we put in the values that we know, so initial velocity is 9, displacement is 3.15, acceleration is minus 9.8 or minus 10 in this particular substitution, we get the velocity works out as, I think it's the square root of 18 is what it works out as, which is a positive value, meaning it's got a positive speed at the ceiling, meaning it will strike the ceiling again. Okay, for you, pause the video and do 2019 5B from the ordinary level course, or the ordinary level papers. It looks like that. So pause the video, but I'll keep going. A ball is fired vertically upwards in a room with a smooth horizontal floor and ceiling. The room is of height 3.2 meters. The ball is fired up at a speed of 12 meters per second from 1 meter above the floor, and the coefficient of restitution is 3/5. So it's almost identical to the previous question. We want to find the speed of the ball immediately after striking the ceiling. So we know that it will travel 3.1 meters up with an initial speed of 12 and an acceleration of minus 9.8. We'll see minus 10 will be used here. That will give me the velocity it strikes the ceiling with. We then use the coefficient of restitution formula to get the velocity it rebounds off the ceiling with. And that's what the first paragraph is there. So the V equals 10 is the speed it hits the ceiling with, and using the coefficient of restitution, it rebounds with a speed of 6 meters per second downwards. Part 2 is the same as the previous question also. Will it strike the ceiling again? So we need to separate this into 3 sections. The ball downwards, what's the speed it lands at? We can see there in the second paragraph we get V is equal to 10 once more. The rebound velocity at the floor using the coefficient of restitution is 6. And then what we want to do is see, does it have a positive velocity when it strikes the ceiling? So we know the initial velocity at the floor is 6, g is minus 9.8, and the displacement or the distance is 3.2 meters there. So v squared is equal to u squared plus 2as, and we'll actually get either a square root of a negative number or a negative number for the velocity there, which means it doesn't strike the ceiling. The method that's used in this particular marking scheme is they've tried to identify how far the object travels before it stops. So they said the final velocity is 0, initial velocity is 6, acceleration is minus 9.8 or minus 10 in this case, and then they're trying to calculate a displacement value. If that displacement value is equal to 3.2 or greater than 3.2, it strikes the ceiling. If it's less than 3.2, it doesn't strike the ceiling. And we can see there from the conclusion, it does not strike the ceiling.